structure like this, then you can do two things. For making this structure, you can just melt the whole structure and make a T kind of what cavity and pour that liquid metal. This is one kind of process. And today you are going to learn what is welding processes. That is another kind of manufacturing process where just you have to what melt at this zone. I'm sorry, this is not working, but you are going to melt at this zone and let it fuse and let it solidify. You will get a T structure. Okay. So what you are doing? You are skipping casting processes to make this T structure. So you removed one complete manufacturing process. So what will this will help what? It will minimize the cost. So manufacturing process is not only about making product, it is also about minimizing the cost. Now I'm going to the slides. Just anybody just confirm me that are you able to see the slides?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now see
Sir,
joining
but will it
processes.
also affect the strength of tea?
Strength of yeah. Strength of in further when you I will show you the figure of welding. Then I will tell you the metallurgical parts. So how strength is varied in welding. Okay. Now, see, joining processes. It has been categorized into three parts. One, welding. Second is brazing, soldering, adhesive bonding. And third is the mechanical assembly. Now, in mechanical assembly, these are what? Threaded fasteners, like nut and bolts. So here in mechanical assembly, you can deassemble and again assemble. The assembly and deassembly is very much easily. Means it is a temporary attachment. Okay. And in the second type of joining process, which is brazing, soldering, adhesive bonding, we simply use a low melting point material to join two substances. Okay. Example you have seen when some electricians they repair the motherboards of TV computer, then you can see that they are using a low melting point material to just adhere the what electronic chips or electronic components into the motherboard. So they are just using low melting point metals to join or for joining processes. And the first one joining process is welding. So welding is a kind of what permanent joining. You are joining completely or permanently. Now let's proceed. These are some of the examples. See here nut and bolts. This is a kind of mechanical bonding. Here brazing joint. Here you can see the joining or that liquid metal has been in this cavity. So in this kind of joining process in brace joint, uh, the liquid metals also get sucked into this narrow cavity with the help of what capillary process. And this third one, the welded joint. Here this one is one part or this one is another part, they has been joined by just fusing the common section here with the help of some source of heat. They has been melt and fused in the molten state, and it has been solidified. Now, one of you students ask that strength partner. Okay, now see here, this one is in the central part, this one is the liquid part. Then after that, this one is the heat affected zone. Then after that, this is the unaffected heat zone. Here there is no effect of heat. Now, for the strength part, I am going to some little bit of metallurgical part. When you will see a metal or any type of metal under high magnification microscope, like electron microscope, then you will see that they are made of small grains attached to each other like sands. Okay, now as smaller those grains will show higher strength as compared to larger grain size. This is you can understand this like that if grains are smaller, then there are more adhesion between, or they will get more interfaces to attach or for bonding. So they increase the strength as compared to larger size grains. And those grains are very much sensitive to cooling rates. Cooling rates mean a rate of temperature. Now, here in this heat affected zone or the melted zone, when the welding process is done, then only process left was cooling. Okay. Now here in the molten zone, the temperature is very high. So here the cooling rate will be very high because temperature is very high. And if say it is in air, so what the lower temperature is ambient, so temperature difference is very high here, so rate of cooling will be very high here. And after that, in the base metal where heat is what penetrated to this zone, heat affected zone, they will also have some cooling rates. So they have different kinds of what grain structure or grain sizes. Okay, now you can control this cooling rate to just control the strength of the material or the weld. So am I clear? Whose doubt there? Some students have doubt. So am I clear? Now I'm going to next slide.
Yes, sir.
See, uh, here some applications. If you have any doubt, though, in between you can ask. Okay. Now, these are some of the examples of welding. Here you can see that welding, with the help of welding, they are repairing some ship, larger ship. Okay. Here some aircraft industry, here automobile industry. Now, welding process features. So welding, as I already told you, that in welding you are making a permanent joint with the help of temperature, suitable combination of temperature or pressure. And second feature is formation of common metallic crystals at the joints. This second point you can understand by simply that they are making the weld part coherent metallurgically. That I metallurgically means the metallurgical properties are same with the base metals like the grains. If you are talking about the grains, then that is also a metallurgical aspect of explanation of what their properties or strength properties. Now third is
Sir,
with or sorry.
sir, please explain second point once more.
Here it was written that common metallic crystals. Okay. So crystal, one crystal you in your chemistry part you have studied that iron have crystals BCC, FCC, you know.
Yes, sir.
Okay now. So what is if you have uniform crystal structure throughout the throughout the metal or workpiece, then you will get a uniform strength.
Yes, sir.
Now, so what in the motto in welding process is to match the weld crystal metallic crystals with the original base metals. Am I clear? This is the motive to make a uniform strength. Am I
Okay.
clear?
Yes, sir.
Now, third point is with or without materials. Let's say you are going to join two slabs. I'm using, say, you're going to, why this is not working? Say, you are going to join two slabs. Now the thickness is, say, they have thicknesses of 10 mm or 15 mm. Okay. Now you are going to join at this section. So you have to what? You have to melt the joining or here this uh, space. Now say if the thickness is sufficient, okay, then you no need to pour some extra liquid material to join because the thickness is sufficient, so there this common or this edge part will melt and join, so you don't need a filler material for joining process. This is here the third feature. You can use welding process with or without filler material. Now, what are the advantages? Uh, First, you are getting an exceptional structural integrity. Okay.
Sir, sir, how we will know that the thickness of the material is sufficient to be welded, or means
Uh,
no other material is required?
Means this is operating part. It is just like one student don't know how to ride a cycle, and you are asking him, and he is saying, "How I don't know how to balance the cycle while pedaling the pedal." So one can only say how you are not using, who is already used that, some is operators, or say you are welding something, then after some time you will know or experientially how you are not going to use a filler material. And if you don't know, then these datas are also available in some record books. Okay.
Means, sir, only
Sir,
experience is necessary. No mathematical calculation
Means
or formula is.
no. It's like from the beginning when they started, then they knew this experientially. Then they have noted down now, or they have made some notes. They have published papers. Then after that, you can get those records from books or what from internet, so you don't have to need extra what experience to know which part will not require extra filler material. Okay. Now here,
sir,
hmm, okay, ask.
sir, what's the temperature range for welding?
It will depend now, like for melting iron, the temperature is around 1500 degrees centigrade, so it will vary for metal to metal.
sir.
Now the second, if am I clear?
Yes, sir.
Now second advantage is strength of the joint can approach or exceed the strength of the base material. I already explained. You have the motive is to make uniform strength, and if you are getting a more strength, then it is okay. Third advantage is wide range of processes and approaches. Means you have difference various. In this slide you will know two kind of welding process. One is chemical process, that is oxyacetylene, and another is arc welding process. Two category, two types of, but there are other kind of welding processes like electron welding, laser banging, so wide range of processes. Fourth advantage is can be performed manually. As you have seen in roadside garages, they are welding manually, the garage operators. You can also use semi automatically, and also you can use completely automatically. Completely automatic, it will help where the environment is hazardous, where human cannot reach, so you can use robots for welding purpose. Now, what are the
Sir,
disadvantages?
sir,
Hmm.
so in first point, the exceptional structural integrity and continuity and fluid tightness, I didn't understand of this word, sir.
Yes, sir.
Can
What
you
Uh,
does
explain?
fluid tightness mean?
Here, this first structural integrity. Okay, so this is a term, technical term for a complete, uh, say complete required or desired property of the weld. So you are getting a exceptional structural integrity means you are getting better strength, you are getting better metallurgical properties, you are getting better, means you got, it simply says you are getting a exceptionally good weld. Now continuity, so you will get a continuity in will get continuity in strength, you will get continuity in crystals, as in the previous slides, common metallic crystals. Now fluid tightness, so when the molten, you know, surface tension, you know, then liquid, they have surface tension, or they have surface tension, they have properties, they have at the surface tension. So fluid tightness at the at what, at molten state, you don't need or you don't have to worry that whether it will fill the gap or not. With the property of surface tension, it will tighten itself at the cavity. Okay. Now portable equipments, you know, you can carry wherever you want.
Sir, sir,
Hmm.
so actually surface tension is so weak for, so it is affect this term
Uh,
for fluid
Whatever
tightness.
it will see this figure. Okay, this is two parts where this one is the liquid metal. So say if say the surface tension is very weak, so it will what, you know, when the contact angle is more than 180, they leave the surface. Okay, now like
Yes, sir. Yes, sir.
okay, now so if that surface tension is not desired or favorable to this surface, then it will what, leave the surfaces, so that filling tightness
Okay,
will
okay.
not
So got it.
be what now.
So,
Yes, sir. Yes, sir.
Now
excuse me, sir. So in hello.
I am listening.
So in the welded joint diagram, there was
Yeah.
a part which showed unheated base metal.
Yeah.
Sir, so
uh,
uh,
mhm.
when we fuse the above part, won't some heat come there also by conduction?
Yeah, that is why you have a heat affected zone up to here. Then after that, you are getting unaffected zone, means heat will penetrate. Heat conduction is what is, it is a parabolic function, parabolic decreasing function. Then after this zone, you will won't get any effect of that heat penetration of conduction.
Okay.
Uh,
Okay.
Now what I am doing, if you have doubts, if in this way it will take more time, so you just write down your doubts on the text box, then after explanation I will clear your doubts. Okay, now here the welding process disadvantages. First one, preclude de-assembly, means de-assembly is not possible, you are making a permanent joint. Second disadvantage, requirement for heat in producing many welds can disrupt the base material microstructure, degrade properties, may induce residual stresses. So what is happening with the introduction of what heat? You are just changing the microstructure, means metallurgical properties. So the metallurgical property of the what material or weld is changing. So this is also an advantage. You have to make a desired microstructure or metallurgical property to get a uniform strength. And with the introduction of it, you also introduce residual stresses. These are kind of permanent stresses within the lattice, within the material. So this is will also hinder the property or uniformity of strength of the material. Now, third disadvantage requires considerable operator skill. It is like in roadside garage, you have seen that they are welding cars or chassis or whatever things they are welding. So if the operator is not, hello, am I audible? Hmm.
Yes, sir.
Yes, sir.
So if the operator is not skillful, so their welding will be not as much good as the weld done by a skillful operator. Now, fourth disadvantage is capital equipment can be expensive. As I showed, there are other type of welding processes like laser beam, electron beam welding. So those equipments are very much expensive. Now, what are the basic elements of welding setup? You need a energy
So,
source. Uh,
so, so actually, in disadvantages, first point is the precludes disassembly. So, but we use a low temperature material to join them. So after heating, it will not remove.
that is a brazing welding. Second kind of welding, joining process. This is welding.
Okay.
That
Okay.
means it is a
So
permanent joining.
Hmm. And kindly, if you have doubt, then write on the text box after the slides. I will make your doubts clear. Now, what are the
yes, sir.
basic
So
elements? Elements, what? You need a energy source for the melting process. And before doing welding, you have to make sure that the surface is not contaminated. You have to remove the surface contaminants. Now, third element is protect the metal from atmospheric contamination. When you are welding, when the metal is in liquid form, then it can catch oxygen and make metal oxides. So those are not required. So you have to protect the atmospheric contamination also. Now, fourth element is control the weld metallurgy. Weld metallurgy, I already told the metallurgical property, how we will manage just by controlling the cooling rate. Now, here is a term power density. It simplify or it simply explains the power transferred to the work per unit surface area. Here, some of the examples is given or data is given. Now, where you have higher, let's say electron beam welding have very high power density. It means per unit area you are giving very high power, very high energy rate, so you will melt very quickly. So that is this second point. Time to melt the metal is inversely proportional to the power density. More the power, lesser will be time to melt. Now this the first kind of welding process you is oxy fuel gas welding. So in welding process, first you need a energy source in the form of heat. So here you are getting heat out of chemical fuel or chemical energy. So what happens? You burn the chemical in presence of some oxidizer, say oxygen, to get the heat. So here you are using the chemical is acetylene, but you can also use hydrogen, natural gas, methane, propane, butane, and any other hydrocarbons. So what you do in presence of oxygen, you burn the fuel and get the heat source, and what that heat source is used for melting, for joining. And acetylene is preferred because you get very high temperature in acetylene. Now, these are some datas where how much peak temperature you are getting with using these chemical fuels. And here in the second column, the heat of combustion is given. See, for acetylene, you are getting very high peak temperature, 35 degree, 3500 degree centigrade. Now here, see, this is the tip. And before going, okay, before going or before explaining the oxyacetylene welding process, you should watch the video so that you can understand very easily. Okay, but before that, I am just explaining the setup. Okay, this one is the setup. You have one acetylene cylinder and another cylinder is for oxygen. They are connected with hoses to a common torch where this acetylene and oxygen gets mixed up. This torch, the stream of this combination is coming out, and when you apply ignition here, then you will get a fine or what fine diameter or concentrated flame of heat, and that heat is used for melting the metal for joining process. Now see the video I am sharing. Acha, somebody just confirm. Can you see the video?
Yes, sir.
Yes, sir.
Yes, sir.
Now
Sound is
see the
not there.
video how they are
Yes, sir.
welding.
Sir, sound is not there.
There is no sound.
Sound is not there.
Acha, let me check.
So the gas welding. So you are not audible.
Sir, please start the video again, sir.
Yes, sir.
Yes.
Yes, yes, sir. Sir, sound
Sir,
is
you are
mute.
on mute. The video is stop. Yes, sir, mute.
Sound is not coming, sir.
The sound is not coming.
Sir, not audible.
Not audible, sir.
Rakho, the audio is not coming, so you have to unshare and keep the include all. Please unshare. So unshare and again share. No, not this way. It will not come. See, please unshare first. Completely unshare your screen. Completely come out. Completely come out. Unshare your screen. Yes, unshare. You are still sharing your screen. Okay. Now you again share, but before sharing a particular things, there is a button. So you include on, keep that thing on your share screen before you select a window. Include for all. There is a button on the left top corner of the share window.
Still, the audio is not coming.
Audio is not
Yes,
coming.
sir. Still.
Yes, sir.
So if you have problem, I am.
Hello.
Yes.
Sir, I'm doing the same thing, but sound is not coming. So maybe some
Just let me
technical.
play from my end. You just
Yes, sir.
unshare.
Yes, sir.
Just a minute.
So the gas welding, here we are using oxy-acetylene gas welding. What are the equipments?
Yes, sir.
Yes, sir.
First, you need two gas cylinder. Here, this one is the oxygen cylinder, and this is the acetylene cylinder. Oxygen cylinder is black in color, and acetylene cylinder is maroon in color. Different color code used for different gas cylinder. And this is the main valve of the oxygen cylinder, and you have to open the main valve using the valve key. And here this is the acetylene cylinder, also you have to open using the valve key. Now you have to set the pressure. This is the pressure gauge, oxygen pressure regulator, and this is the acetylene pressure regulator. In each regulator, two pressure gauges are attached. First one indicates the internal pressure of the cylinder. The second one indicates the working pressure. And now the internal pressure, when it is fully filled, the internal pressure maximum show up to 154 kg per cm square. Now it is near about 10 to 15 kg per cm square. And now you have to set the working pressure by rotating this knob. Now I am setting working pressure near about up to 1 kg per cm square. And you see, when this tank is fully filled, this will show 17.5 kg per cm square pressure. But now it is showing near about how much? 3 to 4 kg per cm square. Now you have to set the working pressure of acetylene. I am setting generally for two types, low pressure welding and high pressure welding. For low pressure welding, I am setting about 0.15 kg per cm square pressure, and for high pressure welding, I am setting up to 0.6. Okay, now I am setting near about 0.5 kg per cm square. And these are the two safety devices attached here. This name is flashback arrestor for oxygen, and this is for acetylene. And two hose pipes are connected here. And for oxygen, hose pipe color is blue, or you may take black in color. For acetylene, the hose pipe is red in color. For different pipe also, color code is used. And these two hose pipe are attached to the welding torch. You see, red one is connected to the acetylene side. Now if you open this now, maroon color now, acetylene will flow, and if you open the black color now, then oxygen will flow. These are the two flashback arrestor also attached before the torch for safety purposes. Now this one is the torch, and this one is the tip of the torch. You can see also this type tip of the torch which is attached here. And generally different number, 2 number or 3 number according to the hole diameter are using different tip to the torch. And now you have to set different types of flame. And here these are the two plates. You see, these are two mild steel plates. Thickness is near about 2 mm. And you have to join the two plates. Suppose I will go for the board joint. And since it is very thickness is very less, so directly without using filler rod, you can also joining the two plates. Generally, according to these are the filler rod where you may attach at the time of folding to increase the strength also. The filler rod material should be similar to the base metal. Since this base metal is mild steel, the filler rod is also mild steel. So according to the use of filler rod, generally 3 types of joints are done. One is the autogenous. Autogenous joint is without using filler rod, only by hitting the plates at their contact edges. And if you join these two plates, that is autogenous type. In homogeneous type, generally autogenous is used for thin plate up to 3 mm thickness. You may take the autogenous process. If it is more than 3 mm, at that time you have to beveling the edge. After beveling the edge, if you go for the holding the two plates, you have to also fill the groove. At that time you are taking filler rod, and if you take the filler rod and go for the holding, that type of joining process is the homogeneous process. A filler rod material should be similar to the base metal. And heterogeneous is the process. In that process we are using filler rod, for the material is other than the base metal. Now I will show you the different types of flame. Generally, neutral flame is widely used in gas welding, but I will show the three types of flame. First, before going for the flame, first you have to open the acetylene needle valve. Just rotate it slightly and see and check the acetylene is flowing or not. Then by the help of the lighter, and you have to burn the and now you see this. Now acetylene is only burning, taking the oxygen from atmosphere, and gradually you have to increase the acetylene volume. When you see smoke is ceased, at that time you have to open the oxygen. Now if you open the oxygen needle valve, then when oxygen continue to flow, at that time you see acetylene is gradually consuming acetylene is increased. Unburnt acetylene will come less if you increase the oxygen gradually. Now you see the flame, how the flame is changing, and this is the initial flame, and this flame is called as carburizing flame. You see there are three types of layer is coming. One is the outer envelope, and the middle one is called as acetylene feather, and the middle one is acetylene feather. The middle one is the acetylene feather, and the inner one, which is nearer to the cone, that is called the inner cone. And the mainly three layers are visible, and more temperature is developed at the inner cone. In this flame, the carburizing flame, the temperature is near about 3000 degrees centigrade. And this carburizing flame generally used for high carbon steel welding. And now, if you again increase the oxygen, you see what happened to the flame. The acetylene feather gradually length is decreased and decreased. Now you see the acetylene feather disappear. Only two layers are visible, inner cone and outer flame envelope. And this flame is called as neutral flame. In earlier flame, acetylene is rich. That means oxygen is 0.9 and acetylene is 1 part, 0.9 is to 1. And in neutral flame, the acetylene and oxygen near about 1 is to 1. That is acetylene and oxygen equivalent volume. And this is the widely used flame. Most of the welding is done using this flame. And temperature at the inner core near about 3000 to 200 degrees centigrade. And now, if you again increase the oxygen, now you see what changes. Inner cone becoming more sharper and more pointed, and outer flame becoming shorter, and a loud roaring sound is coming. And this flame is called as oxidizing flame. And in oxidizing flame generally used for cutting purposes. And in this flame temperature is the maximum in gas welding. The temperature near about 3500 degrees centigrade. Now, again by decreasing the oxygen, I am coming to the neutral flame, and I will use the neutral flame for mild steel welding. Now I will show you the autogenous part. I will show you the homogeneous process using the filler rod material. And these are the safety This is the welding gas welding goggles you have to use for safety purposes, for safety of eye. And you have to wear this glass. Yes. Globe. Now, first you have to join the two ends, and you have to hit the one end. स्क्रीन बढ़ाता हूँ. Now start holding from one end. First you have to heat the base metal. When it will come to the molten state, then you add the filler rod inside the molten metal and allow the filler rod to melt and deposit at that. And at that time you may give sideways movement to the flame. If you give some sideways movement to the flame, the metal will melt and it will deposit in some more width and material. The strength, joint strength will increase. दिखा नहीं जाता मुझे, दिखा नहीं जाता मुझे, क्या करूँगा? दिखा नहीं जाता. And accordingly you have to add the filler rod and you have to move the filler rod forward and backward in direction and add the filler rod and you have to also gradually move the flame towards the left hand side. And here we are using the left hand technique or leftward technique because it is start from right hand end towards the left hand. The flame angle to the workpiece is near about 60 to 70 degree and the filler rod angle you have to maintain 30 to 40 degree with the workpiece. Sometimes at the time of welding, if you near the tip towards the molten metal, the molten metal may enters into the tip may block. At that time there is chance of backfire. To avoid backfire, and at that time backfire the accident may occur, and to avoid accident we are using flashback arrestor. These are the safety device which are attached to the before the touch and two pairs also attached before the cylinder for safety purposes. And to avoid backfire, always you have to maintain a gap between the tip and workpiece. And backfire occurring due to the suddenly blockage of tip or due to the uneven pressure and more temperature developed at the tip. And this is the bar joint, and this is homogeneous type, and here we have used electrode, filler rod.
Now I'm proceeding. Let me share my slide again. Can you see the slides?
Yes, sir.
So this is the diagram of the just tip of, or say this is the tip of the torch from where the mixture of acetylene and oxygen is coming. This one is the base metal which is being welded. This
Go
one is
to full
the
screen.
yes, sir. This one is the filler material. Here you can see the solidified weld metal, and this one is the flame. Okay. Now see what happens. While combustion of acetylene, the reaction takes place in two stages. Here in this flame, you can see there is one small cone, black cone, inner luminous cone. Here, first stage reaction takes place. You can see here C2H2 combined with O2 get 2 moles of carbon monoxide, 1 mole of hydrogen and heat. And in this larger outer envelope, second stage reactions take place where you also get heat. But you should note that the heat generated in stage 1 is very much higher than is compared to the heat generated in stage 2. Means in this envelope part is basically it is preheating the metal. The basic melting is done by this inner core. Age
Some
temperature.
connectivity issue.
Am
Are
I
you
audible?
getting the screen fully?
Yes, sir.
Slide is visible.
Yes, sir.
It is visible.
Yes, sir.
Go to full screen. Okay, fine.
So now see here, by just managing the ratio of the mixture, that is acetylene and oxygen, you will get or you can get three types of flame. This first one is neutral flame, means here complete combustion is happening, means the ratio of means the ratio of acetylene and oxygen is stoichiometrically balanced. But say if you are supplying less amount of oxygen, then complete combustion of acetylene will not take place. Then that flame is called carburizing flame or reducing flame. This third flame is that kind of flame. But now if you are supplying more oxygen as compared to the neutral composition, then you will get a oxidizing flame. Means in this flame extra amount of oxygen will be there, which will help in further metal oxidation. And here in reducing flame, you will have some extra unburnt acetylene. This unburnt acetylene feather you can see is called acetylene feather. So it will help in some metals like low carbon steel, it will harden the surface. So this flame is used for surface hardening. I will explain later. Now see, sorry, reducing flame, what it does. So reducing flame for removing oxides from metals such as aluminium or magnesium. So reducing flame, removing oxides from metals such as aluminium and magnesium. How they are removing is reducing flame has unburnt acetylene. So it will what? It will try to capture oxygens molecules wherever it finds. So aluminium oxides, it will try to capture the oxide of aluminium. So it will take and form another type of compound, and it will remove those things, those metals, aluminium oxides or magnesium oxides out of the molten metal. And how this removal happens? Normally oxides are less denser, so they simply floats on the surface of the liquid metal. Now second point, preventing oxidation reaction during welding. Now here is what, when that oxide layer is on the molten surface, then it will again make a further protective layer. So now it will what, prevent further oxidation within the molten pool. Now third is to prevent decarburization. So it prevents carbon to convert into carbon monoxide. Now third is low carbon alloy steel, monel steel for hard surfacing. Let me explain some bit more for the last point, how it hardens the surface or how hardening happen. Is this flame is reducing flame means there is extra amount of unburnt acetylene. So Acha, what do you mean by a strength? Say if I am giving you two materials, material A, material B, material A required say 500 Newton to deform, and material B required 600 Newton to deform. So whose strength is more?
Six
The
hundred.
material requires
Second.
B.
to deform.
Metal B. So in terms, you can define a strength or hardness is what? It is the resistance for deformation. Okay, now say for take any crystal, say iron crystal. It has some crystal means arrangement of iron molecules. Okay, and in between iron molecules there are some empty spaces. So if you introduce or infiltrate some another kind of smaller atoms, say carbon atoms, in those empty spaces, means you are filling the empty spaces of that iron lattice. Okay, now do you think now the deformation require more force? Hello, are you getting?
Yes, sir.
Hmm. So what happens
Yes.
here, hard surfacing, is you have unbound carbon molecules which is not combined with oxygen, so they infiltrate in those empty spaces of low carbon steel lattices, and it then what, it hinders or it resists further deformation, means it will what, hardens the surface by just introducing extra molecule carbon atoms in the empty spaces of iron lattice. So this is how hard surfacing is done. Now, oxyflame. Here you have more amount of oxygen. Means what? Oxygen will try to oxidize the molten metals. So, first point, see, the oxidizing flame causes the metal being welded to form an oxide.
Sir, no sound.
Sir, you are not audible.
Now, am I audible?
Yes, sir.
Yes,
Yes.
but your video has gone.
Now, can you see the slide?
Yes. Rakho, full
Yes,
screen.
sir.
Full screen. Now, see, second point, useful for preventing the loss of high pressure components such as zinc out of brass through the formation of an impermeable outer skin. It is oxidizing flame. So initially it will oxidize the liquid and as oxide liquid means metal oxide is less denser, so they will float over the surface of the molten metal and it will make a protective layer. So those protective layer will further what protects to for escaping of high vapor pressure metal such as zinc out of brass. Okay, this is the setup I explained earlier and it is also explained in the video, so I don't need to explain. This one. This is the figure of that torch, and this one is the mixture zone. So this is the cross section of this part. This part you can see arrow has been drawn. So you can see oxygen is coming from this path and acetylene is coming from this path, and here mixing is happening. Now, this one is a simple question. Maybe it won't take much time. Take 5 minutes or 7 minutes and solve yourself. And you can say the answers or you can write in the text box. Here consider the heat of liberation is considered for only stage 1 reaction, because in stage 2 the heat generation is very lesser compared to stage 1, so that has been practically neglected in this question. Or anybody if still has any doubt, then why they are not considering carbon monoxide, then for your information I am just telling you why it is neglected. Because carbon monoxide heat of combustion is something 283 kilojoule per mole, and for acetylene it is 1300 kilojoule per mole. So now you can see how much difference of heat liberation. If anybody has doubt in understanding, then you can ask which part you are not getting.
The first part is 165 into 10 power 5 joule.
Uh, just write your answer in the text box because others are also trying, and after the limited time I will show the answers so you will match.
Sir, the work surface is the circular area only, no?
Yeah. Now I think many students have got their answers. Let me just check. Yeah, answers are coming. So now I'm showing you the answers. See, did you get these answers? Here in first question, the amount of heat liberated. So you are simply multiplying the combustion amount of